So this is a compass. You all must have heard that a compass shows the north direction with its most prominent, say in this case, the red color arrow, and otherwise also in bags, in pencil boxes nowadays, the compass is already inbuilt. But have you ever wondered that in the ancient times how sailors used to navigate? They used to navigate with the help of stars. But when it was a windy night, when the clouds were covering the sky and we could not see the stars, what they used to do in the middle of the sea? Will they not get lost? So this brings us to our today's chapter from the NCERT series which we were discussing, and that is about magnets. This is chapter number 4, Exploring Magnets. So let us get started. The entire chapter starts with a story where a young girl, she wants to write a story and she is a storyteller. So she writes a story, and when she was writing it, in the middle of it, the story went like, okay, they used to get the directions with the help of stars, but on a cloudy night, on a stormy night, now what will the sailors do? Will they not get lost? So she was stuck and she could not write what will be next after this. So in ancient times, there were some naturally occurring rocks which were known as lodestone. Lodestones were used as the natural, say, direction giver. It was like the magnets, or it was like the compass which we use in present times. So how the compass is always used to point to the north direction? It is because the earth itself is also a huge magnet. The reason? Because the outer core of the earth has the nickel, we say knife in short, sial sima knife. So knife means it has nickel and iron in its outer core, because of which the earth itself acts like a huge magnet. Still curious about how this is actually happening? Let us get to the details of this chapter. We can see commonly in, say, the pins which are there stick to the pin box. Some of them are sticking in the surface and not going down. Why? Then there are magnetic boards where the duster will be attached to the board itself. In the phone covers, in wallets, purse, etc. also the magnet is used, say, to stuck it somewhere here. That is done with the help of magnets. In pencil box, in the wardrobes, there are magnets attached, right? And then we have the fridge magnets, which are very beautifully made, and then it can be sticked on the fridge surface as well. So these are the commonly seen magnets in our day-to-day life. A magnet can usually be, say, of bar shape, which is like a bar, and it is the bar magnet. This is the most common one. Then we have the U-shaped magnet. This is a little bit less in the households, but another is the horseshoe magnet, which is used, say, outside the door or as a symbol of, say, protection. And then we have the ring magnets, which are circular in shape. So these are the different shapes of magnets. However, it is up to the human, because nowadays we make the magnet, and we will see in this class also how to make a magnet. So we can use any shape because it is human made, right? So it can be of bar shape, bar magnet. It can be of disc shape. It can be of cylindrical shape, ring magnet, spherical magnet. All these shapes can be there. However, if we are using the word magnet, that means it has to have a north pole and a south pole. Just like our earth has a north pole and then we have a south pole, similarly a magnet will also have a north pole and a south pole. Doesn't matters into how many small pieces we will cut this magnet. It will always have a north pole and a south pole. Let us understand this in details in the future slides. Now, unlocking the first secret, that is the power of attraction. If we have, say, a lodestone, then the first clue to the lodestone's power is that it does not attract anything. It interacts only with specific materials. This property divides the world into two categories for the magnets. Those who are attracted to, say in case of when naturally they used to see and find out the things, in that case we can call it as those who are attracting and those who are repulsing. Now that we are using the term magnet, we can say those who are magnetic materials, that is they are attracting to the magnets, and those who are non-magnetic materials, that is they do not attract with the magnets. Now who are these who will attract to the magnet? These are the items or the materials which are made of iron, and not just iron but also nickel and cobalt, or in different proportions of these materials. Then we have the non-magnetic materials. Anything which is not in these materials or a combination of these materials, that is wood, plastic, glass, rubber, anything for that matter, these substances will not attract to the magnet. That is, we need the combination of iron, nickel, cobalt, any of these combinations or themselves to be attracted by the magnets. Now coming to the North Pole and South Pole. Doesn't matter into how many pieces we are cutting a magnet, it will always have a North Pole and a South Pole. And if we place some small iron needles or some small iron nails, we will see that the nails will attract in this pattern. And we can clearly see here more attraction is there. And number 2, in the poles, in both the poles more attraction is happening. If we see in this region at the center, there are very few pieces which have stuck. So by this we can say that the clear pattern here indicates that the force is not evenly spread. It is concentrated in the north and the south poles. It is concentrated in both the ends where the magnetic poles are there. Every magnet, regardless of its shape, size, how small we are cutting, will definitely have a north pole and a south pole. It is not possible to exist without both the poles. It is impossible to be a magnet with a single pole. So both the poles are compulsory to become a magnet. Now coming to a freely suspended magnet. If we keep a magnet freely suspended, or if we hang a magnet, then always we will see that the magnet will point towards the north. This we can see if we have a, say, compass, or otherwise we can see it is not generally written whether there is a north pole and this is the south pole. However, towards the north sometimes there will be a white colored dot. This can be there, and sometimes even though nothing is written, we understand that it will align towards the north-south direction only. Why? Because the earth itself, as we have discussed, works like a huge magnet. Okay. The north-seeking pole or the north pole is the end that points towards Earth's geographic north. So, wherever the Earth's geographic north will be there, that one will be the north pole or the north of the magnet, because it is towards the Earth's geographic north, or in this case the white dot will be towards the Earth's geographic north. If we take the compass inside a room, then we will see that the north direction is clear. So we can find out which is the east direction, west direction, etc. Now see, in the south seeking pole is, or the south pole is the end that points towards the south. However, if nothing is there on the magnet, no north pole, south pole is mentioned, or no white dot is there, in that case, we know that it has aligned in the north-south direction, but we cannot exactly point out which is the north and which is the south. So in a freely suspended magnet, it will always point towards the north. Then we can make a dot there if we want to. Now from discovery to device, the magnetic compass. We understood that okay, lodestones were being used. Now we have magnets. Now we have the purpose that we should make something which will always point towards the magnetic north. So that brings us to a magnetized needle. We will also see how to make it. A magnetized needle. Now as we can see here, this tip, this is colored in red. This point is always pointing towards the north. Now here, that means this is the north. So it will always point towards the north. It is not to be confused what is written on the, say, this dial, but wherever the red arrow is, that is the exact north. The needle reliably aligns itself with what? With the Earth's north-south magnetic field. And the dial marked, it will have the rest of the indications like east, west, north, south. So like this, it will be indicated. So it will, generally it has a red color. This diagram also has a red color, and the one which I have, this also has a red color. Now how do we make our own compass? Is it possible? Yes. We take a simple needle, the needle which is used to put a thread and to sew the cloth. So that simple needle we will take, and step number one is we will magnetize the needle. How do we magnetize the needle? We take a permanent magnet. It is easily available in the household. If not, then we have to perform this with the help of a magnet. We have to get it, or we have to borrow it, or in the school, in college, in the university it can be done. And then what is being done is in one direction itself. Just like when we beat coffee, if you want good coffee, you have to beat it in one direction itself. So similarly, in one direction, it is being again and again rubbed against the needle. What happens in this is, if this process is done for say 30 to 40 times, in this case, the needle gets magnetic effect. So the needle also becomes a temporary magnet for some time. Now create a pivot. So carefully pass the magnetized needle through a small piece of cork. That is, for example, if we have the wooden caps of the homeopathic glass medicine bottle or any other alternate options, we can pass the needle through this and we can float it in a bowl of water. Now what happens, this face of the needle, obviously what will it indicate? Any guesses? You can put that down in the comment box. The needle will slowly turn and it will come to rest at some point. And just like the magnets which were in freely kept or freely suspended, it used to always show the north-south direction. Here also it will align in the north-south direction. So this is how our compass is ready with the help of a very simple needle. Now coming to what we used to use in ancient times. So like this, anything can be magnetized which has iron, cobalt, nickel. Now in ancient times there used to be the Matsya Yantra or Mach Yantra. This was something which used to look like a fish-shaped iron piece and a fish-shaped iron piece. Okay, and then there used to be oil, and I tried to get the image as well from the internet, but everybody was showing the yantras which are for the spiritual purpose, for religious purpose, for astrology purpose, but I could not find the image of the compass. So that's why I did not put it here. But it used to have oil, and that is how it used to be, say, doing its function as a magnet. Now coming to unlocking some more deeper secrets, that is the rule of interaction. How does these magnetic interactions actually happens? Magnets don't just point north. Of course they do point north, but what's more to that, they also exert forces on each other. Say for example, if there is if we take two magnets, okay, then one magnet will have the north and south, and another magnet will also have the north and south. If we bring the north pole towards the south pole of another magnet, in that case, as we commonly say, opposites attract. So here also the opposites will attract. Of course, if this is south, then this will be north. If this is the north, then this will be south. So the opposites will attract. So the unlike poles of the magnet will attract, or the north will attract to the south, and vice versa. And what is repulsion? Repulsion is likes will repulse. That is, if one north pole, south pole magnet is there, and another magnet also, we took the north pole here and south pole here, that means it will repulse. It will move away. It will repulse. Doesn't matter how hard you try, it will not come close. It will move apart. This you can see if you have any magnet with, say, a white dot towards the north, then also, and otherwise also you will understand. Once you take the magnets, you will understand that these sides are repelling. That means these are unlike sides, or the unlike poles, dissimilar poles. Okay. Now the true test of a magnet is repulsion. Why? Because attraction, iron pieces will also have. If we take a magnet and iron, magnet nickel, magnet cobalt, that will also have. So attraction is not a unique test. Attraction will happen with paper clips, needle, or anything that has any of the iron, nickel, or cobalt component in it. But repulsion is the unique test. This repulsion will happen only in case of magnets, and that too for the like poles it will repulse. Okay. Therefore, while attraction indicates a material is magnetic, repulsion is the only definitive proof that an object is itself a magnet. This is how. What is the real test? If we have the options, then we can select repulsion. For magnetic material, attraction can be, but for the product itself, object itself to be a magnet, it is repulsion. Now see, sometimes nowadays we see some people are showing magic, or they are trying to fool other people by moving things on the table. They are sitting on this side, speaking big words and moving things just by looking at it. How does it happen? Because you have only seen the top of the table. You don't see what is moving below the table, and that is a magnet. See, without touching this pin, I can move it. How? If you put a magnet here and you pull this up, obviously it will come out, right? So that is how you can show magic, by moving objects on top of the table as well. Just before some time, I have discussed this, that the North Pole is indicated with a white dot sometimes, and sometimes it is painted red, and the South is painted blue. So for the North, we have the colors white and red, and for the South, we have the color blue, or it is left colorless also. from ancient navigation to everyday magic. We had the word lodestone for ancient times, and in present times we can see that magnets are used for decorative purposes, for games. We have chessboards which have magnets attached so that it is easy to play even in say a train or traveling. So in those cases it can be used. Coming to how do we handle and store the magnets. Magnets can lose their properties if they are mishandled. So that is why it is essential to know some do's and don'ts for magnets. Let us see what not to do. Number 1, do not heat, hammer or drop magnets. But dropping magnets, if it just breaks into two pieces, you have two different magnets with, of course, both the poles has to exist in each one of them, which happens by default. But still, do not drop them. Okay, this can disrupt their internal magnetic alignment. Next is to keep away from sensitive electronics like mobile phones, computers, credit cards, etc. I don't know how many of you have actually seen that time. If few years back our mobile phones used to be near the television, then we used to know few seconds before the phone is about to ring. There used to be some fluctuations because of which we used to understand, okay, a phone is about to come. So if you have been through that time period as well, then you know, if you know. Now, proper storage. How do we actually store them? To keep bar magnets strong, store them in pairs with their unlike poles on the same side. As you can see, this is north, this is south, and then this is north, this is south. So in both the cases, how they have kept it, unlike pole in the, for this one, unlike pole, and for this one also unlike pole. Now what to do with this north, this is like poles, what to do about this? So we separate it with a piece of wood which is placed in between, and then it is separated. Okay, and place pieces of soft iron which are known as keepers across the ends. So these pieces of soft iron which are kept on both sides, these are known as keepers. So this is the proper way to store magnet. I don't think any of us does it in household, and we don't have this kind of bar magnets, right? That is the reason why. Coming to the next one, which is the use in current times. The principles of magnetism are the foundation for incredible technologies and endless games the children can play with them, or even as adults also you can have many fun activities with the magnets, just like I told you, showing some magic skills. The same force of repulsion, this was the true test, remember, that pushes two magnets apart is used to leviate high-speed maglev trains. So this is the use in present times. It is used for leviating. In many online websites, we find leviating laughing Buddhas or other statues, or say the light is leviating and you don't see anything except that, just a light is leviating. It comes at a good price, some 4,000, 5,000 it takes. A circular piece of light is leviating, and then you don't see anything else. The guest will think, oh my god, what is this, very beautiful. But what they have used a magnet, and that is how this leviation has taken place. Then in case of other decorative items also, it does comes, and that is how it is made most of the times. There are some other say ways as well, but this is the most common one. The power of attraction is used in MRIs, that is the medical imaging. In there the power of attraction is used. We say no, there are some rays, so repetitive tests can, so all these things are associated because of the properties of magnetism. Now let us come to some more information about the sailors who were lost in the sea. Remember? So what happens? The fundamental understanding is now moved from that stars to the magnets, and that is how we can find direction. So the solution is to have a compass. Attraction, okay, all magnets will attract, but this is not a definitive test, but repulsion is. Poles we understood from North Pole. North Pole is there, South Pole is there because Earth is also a huge magnet. Magnets will always align in the north-south direction if they're freely suspended, and the north is either with a white dot or red painted, and it will always point towards Earth's north. Okay. Doesn't matter how many small pieces of the magnet we will do, there will always be a north pole and a south pole because both has to exist for the piece to become a magnet. Direction is given by compass, and a free magnet will always align towards earth, north, south. We have also seen how to use a needle to convert and how to actually convert a needle to a, say, compass. Now the interaction, we already know like poles will always repel and unlike poles always attract. So this is what we studied in this particular chapter, which is chapter number 4 of class 6th NCERT, chapter 4th of class 6th NCERT, which is about exploring magnets. I will see you in the next session where we will do measurement of length and motion. Also, I will like to inform you that we are doing live classes on Tuesday and Wednesday at 1 p.m. On 1 p.m. On Tuesday, we are doing biology previous year question, and on Wednesday, 1 p.m. we are doing chemistry previous year questions. So you can join those sessions as well. Thank you so much. If you did like this session, please consider sharing it. Bye-bye.